Hey guys, how's it going? Since our last video update, we've made a lot of progress. And we've all had our roles in the project, and over the past couple of weeks, I've been researching on how relays operate. And after researching that for a while, I think I gained some knowledge about how that works, and I was able to come up with a circuit that should perform the functions that we want our design to do. It's a pretty simple circuit so far. It doesn't have any resistors or diodes or transistors if they're needed. It's just right now building blocks containing power sources and AC to DC converters and a cable splitter for our 480 volt source to our fans. And right now we just want to get this ran by Palo Verde to make sure that they'll accept this circuit and that we can implement this on their transformers. And we also want to talk to the guys at Keller Electric to make sure that, yeah, this circuit will operate like we intend it to, and that they can provide us with the parts that we need. And this is just our first design. We can tweak it a little bit if we find a cheaper part that needs to perform in a different way. It wouldn't be that difficult. So here's the rest of my teammates explaining their part of the project and what they're doing.
Hey guys, my name's Cesar. Since the last video update, I've been researching some possible PLC simulators because that's the next step that we want to do is be able to simulate it, our design. I have actually started researching the PLC, which stands for Programmable Logic Controller, and so they're usually used mostly in assembly lines or devices that need some kind of relay factors and that nature. The most popular PLCs out there in the industry that are used is Allen Bradley's, Simon's, and Omron Zen's. So the next step that I'm going to take with those three simulator companies is that I'm going to research the pros and cons and see which one is going to be most beneficial to our kind of design. And then once we get that, we're going to actually get the green light with Keller and see if that's all good to go with them. So till then, stay posted. Thanks.
Hey, it's Steve again. Just wanted to give you an update what we've been working on for the past week or so. Currently at Palo Verde, I've been pulling up some of the planned drawings to look at where the source power and some of our distribution setup is going for the cooling bank on the transformers. We want to get a better idea of what's going on in there so when we tie in our sensor, everything will work smoothly. Also, I started a DEC package at Palo Verde. The DEC package is a design equivalency change, and what that is like in our case, currently we have those telltales on the transformer cooling bank fans, and what we're doing is we're replacing that telltale, which is currently the indicator of whether a fan's working or not. We're going to replace that with our sensor we're building. So if you're making a design inside the plant that is somewhat of an equivalent change, basically what an engineer does at the plant, we have to use that DEC package to prove that it will be an equivalent change, and we can manipulate those changes once that package is approved. So in order for us as a team to actually get this sensor installed, hopefully by the end of next semester, we'd like to actually have it installed by the end of senior design. This is one of the things that have to be done so that we can actually get it installed in the plant. So I'll be working on the DEC package on the side at Palo Verde when I'm working there throughout the week. And also over the next week, I'll be pulling up some of the dimensions of the current enclosure that's in place with for the current setup so that we can get our new enclosure in place. Thanks.
Hey, since last time, we have started working on understanding more of the soft engineering issues, such as health and safety, economics issues, sustainability, political and manufacturability issues. With these, in the economic setting, we're looking at creating a design that is affordable and is easy to implement and for APS. Also, with the political side of things, Steve just talked a little bit earlier about how we are working on making CED, and this is part of the political aspect of working with a nuclear power plant. Is we can't make changes that are not equivalent to the designs that are already there. And also, we're looking at the manufacturability and using SolidWorks as to get an idea of designs and how they fit into what we already have for components, and if we need to make a box that's bigger to fit the relays in, or if we can purchase one. And using SolidWorks allows us to make a physical model and to be able to manipulate it and see what we may need or to change in the future.